Hello, my name is Matthew, and I have the privilege of being paid by Ericsson to make the world a better place through open source, and for that I'm grateful. I want to share something pretty fun today. Now, I'm sure you've heard about LLM-assisted code generation. Well, I'm a big fan of it. I find that it's a very good assistant and that it works like a very good spell checker. So, what I did was I decided to help myself write a C program for one of the interns. What I needed was something that would generate a vector and that would just keep on adding random names to a vector. And I asked it to make it with lots of functions so that you could have more traceability, and then we could look at the traces together. So here we have the function that was created. I commented out the reserve part because I did ask it not to reserve, but it just couldn't resist. However, we add 100,000 random names into a vector, and hopefully we could see vector reallocation that way. So we ran this. It adds 100,000 elements, and every time it just adds a random name. Then we looked at the trace. I'm just minimizing now. So if we look here, you can see your main function. And then you can see, oh, is this a nice little reallocate? It looks like it. But then when we zoom in, I'm going to show here, add element takes this much time. But generate random name takes about 40% of add element. That seems, I'm going to double click here to here. And if we get the tooltip, I'm going to go up, select the entire thing, and then go look at the tooltip. 60% of the time spent with generate random name. That made absolutely no sense. So then when I zoomed in, I saw that here we had a lot of allocate strings. I'll double click to zoom all the way. Allocate strings, and I wondered, why is that? So when we go back here, we see that there are 20 names and there are 20 strings allocated at every function. And then I remember, C is one of those languages that doesn't really use much in terms of optimization like jitting. So you see this. At every time that generate random name is called, this array is generated on the stack. And then it's deallocated. And people say, oh, it's fast. You can actually see the impact of it. So what I did was a simple fix. I took the function and I moved it one line up, so now it's a global variable. Now if you want to be more elegant, you could just put the keyword static in front of it. But that's a question of semantics. I would not be surprised if it generates the same binary. So let's take a look at the end result of this one. First off, same code. This main takes, I believe, 3 seconds. Let's double click and see. It takes 3.7 seconds. Then, by moving one line of code, we go to 1.9 seconds. That's not bad. And let's zoom in. And now, add element, generate, takes 600 nanoseconds. And to be extra clear, generate here will take, I'm guessing about 5%, 5.05%. So, what is the takeaway? Now, LLM generated code is very easy to use and it's very fast. And honestly, it's pretty, it's easy, it's maintainable. We should not shoot ourselves in the foot by just flat out ignoring such a great technology. However, we definitely could trace it as a way to accelerate the verification, because you are increasing your creation speed by an order of magnitude. Now's the time where you should also increase your verification speed by that order of magnitude. If this kind of problem is a useful one, we would love to hear about it from you. Please reach out. We traced this using UFTrace, and we traced it, but we could have just as easily with LTTNG, and we are visualizing it using Trace Compass, and we could have just as easily done it with the VS Code extension. Thank you very much, and I hope that all your problems become shallow when you have the right tools.